Good evening, everyone, and welcome to the BS and Beer show. BS stands for Building Science, of course. Our topic tonight is making the most of mini splits, sort of a pros and cons, advantages and disadvantages of mini splits. My name is Mike Maines. Tonight I am drinking a Fever Tree Ginger brew from a Maine Beer Me glass. One of our things is we introduce our beverages, beer or otherwise. I'd like to thank everyone in the audience for joining. I'd like to thank our panelists for coming, and I'd like to thank my co-hosts. This switch over to the Zoom platform has been a lot of fun. It sort of opens us up to building science experts from around the country, such as our panelists. But we also, BS and Beer started as a local building science discussion group, and we still strongly encourage that in person when possible, and even via Zoom is great. It's just a lot of building science issues are local, and it's a chance to build a network and share tips and tricks that work for you. Feel free to use the BS and Beer name. We don't have a copyright on it or anything. And if you want some tips, we will be putting some on our website soon. I'd like to thank Green Building Advisor and Fine Home Building Magazine for helping us, for supporting and promoting us. And a video of our conversation tonight will be available at Green Building Advisor, as well as on our new website, which is thebsandbeershow.com. I would like to introduce my co-hosts, Emily, Travis, and Brian, and I will turn it over to Emily.
Yeah, remember to unmute myself. Emily Mottram, I'm an architect here in Maine, so New England. And tonight we have a couple of really great guests. We get a lot of questions on mini splits, so seemed like a great time to bring these guys on. So first we have Jordan Goldman. He's a principal at Zero Energy Design, a design build firm near Boston. He manages their mechanical design practice. Among other distinctions, Jordan has served as judge for NAHB Research Center Energy Value Housing Awards. So welcome, Jordan.
Just one correction, we're not design build. I wouldn't try myself with a hammer.
Oh, all right. We're
or
just
anyone
design.
else that I work with. We're an architecture firm. We do energy efficiency consulting, HVAC design, building envelope design sort of stuff.
Awesome. We have Christoph Irwin. He's the principal of Positive Energy, an engineering design and consulting firm in Austin, Texas. Christoph hosts the Building Science podcast and often works with well-known builder Matt Reisinger. So welcome, Christoph. Thanks for joining us and holding up the non-New England coast here. And we also have Jacob Straub. He's the co-founder and chief innovation officer at Ripcord Engineering, a mechanical engineering firm based in Portland, Maine. Jake is a former test pilot for the U.S. Navy and built himself a passive house. So welcome tonight. Oh, I forgot. I guess can't leave you without this, Travis. Tonight we are having a local IPA. This is a Peaks Organic, so organic and local. Cheers.
Nicely done. That's to you, Justin.
Or Brian.
Or Brian, rather. That's to
It's
you,
Brian. You got Brian tonight. Hey, everyone. I am Brian Pontalolo, editor of Green Building Advisor. I am drinking a home brewed, not beer, kombucha. Grapefruit flavored kombucha. Just popped the first bottle of it today. It's delicious. So I'm glad to have that with me for the evening. So the way this is going to go tonight, we're going to start off with some presentations from our three guests. They'll each take some time to talk about topics related to mini splits. And then after a little while, we'll move into a Q&A part of the program. And the way we'll do that, the way we'll take audience participant questions is through the chat box. And so if you're not familiar with Zoom, if you haven't been in one of these meetings or webinars yet, at the bottom of your screen, you should be able to find the chat symbol. If you click on that, it will open up a dialog box and you'll see that people are already using it. One note about that, if you're new to this, there's a drop-down menu right above where you type your message in there. And you can select particular people, you can select panelists. If you want everyone to see it, you need to select all panelists and attendees, and then we'll see your questions and we'll be able to either interrupt our guests with the question if it seems appropriate or save it for the end. And then towards the end, we'll just sort of let it flow a little bit, and we'll see how the last half hour of the show goes. We're planning on ending around 7:30. And yeah, that's about it for me. On to Travis, I guess.
You don't want to announce Justin? Sorry, Brian. Yeah, so I'm Travis Brungart. I'm a partner at Catalyst Construction here in Kansas City. We're a very small builder, mostly remodeler. And tonight I am drinking a local beer. This is the Boulevard Brewing Company Jam Band Berry Ale. So a little something from the fruity side. I wanted to propose a toast because the whole concept of indoor air quality and the conditioning of our air always makes me think of a song that I remember mostly from The Big Lebowski, Kenny Rogers, and the new edition. If any of you are tracking with me, what condition my condition is in? Oh, I'm going to botch this. Well, I could sing it for you, but you'll all be heartbroken. So yeah, this is an epic fail on the production side at my end. Or is it? So that either worked or it didn't, but that's my toast for tonight. Raise a glass and drink to what condition your condition is in tonight.
Cheers.
Cheers.
Cheers. Thanks, Travis.
So hopefully that wasn't a total fail. Sorry about that. Thought it was going to be clever. May not have landed. Anyway, I do want to move on to our guests because that's why everyone's here tonight. I want to give you guys each a chance to kind of introduce anything else you'd want to add about yourselves or your businesses, and then obviously introduce your drink because that's super integral to the process as well. But a general question for each of you is something I find difficult to get through with a client is why would someone choose a mini split instead of a traditional forced air or radiant system? So if you want to start us off, Christoph, what are you drinking tonight?
This is a kombucha my wife made.
Kombucha, nice.
It's not grapefruit, but that sounded delicious. And your name was Brian?
Yeah.
Okay. Looks like it's fine home building. So as far as answering the question, why would anyone want to buy a vehicle with a carburetor when they could have had a fuel injector, right? It's somewhat of a situation where the prevailing technology is giving way to a new way of working. But we need to get clear on what are you guys calling a mini split? I mean, there's mini splits and there's VRF and then there's 2-stage and then single stage. So unfortunately, some terminology is necessary. When you say mini split, you mean ductless refrigerant line?
That's what I mean.
Yeah, yeah. Or just I think in our world, mini split usually means a ductless air source heat pump. But we don't have to get too into it. I know you each have presentations that may answer this. So I'm guessing your response may be it depends, which is the classic high performance answer.
Hey, that's my word.
to steal from Emily.
Yeah, that should be a drinking game with Emily. Every time someone says it depends, Emily should have to drink. I want to promote that as a concept. How about you, Jordan? Can we move on to you next? And anything else you wanted to add about yourself? And what are you drinking?
Sure. I'm drinking a Montauk Session IPA. So we're a Boston-based firm, but I live in Brooklyn. Although I am quarantining out on Long Island at my parents' house for free childcare. Montauk being a local brewery here. So I mean, I work a lot with mini splits. I consider them any small heat pump, whether it's a ducted or ductless, single zone or multi-zone. I feel like they all fall into the rubric of mini splits. I'll talk about this a bit more in my presentation, but I like them because they're small. They're generally more properly sized for high performance homes. They run on electricity, which means you can offset their energy use with photovoltaics, and you don't have to worry about any natural gas or propane or heating oil on site, which is good for climate change and is good for life safety. You've got no risk of gas leaks. You've got no risk of carbon monoxide poisoning. And I just think that it's moving towards the future paradigm of a renewable energy grid with everything electric based and kind of decoupling from any gas infrastructures.
Nice. Well said. I guess that moves us to Jake. What are you drinking, man?
Multiples. So, I'm
We got
muted.
you now. You're good.
You got me now? Okay. So I'm drinking, I've got, let's see, Stowaway IPA to start with, but I've got a bunch more sitting beside me in case this goes long, you know. Yeah, so why mini split? I mean, there's a bunch of reasons for it. Normally, one of the big ones is cost of the system. They're a pretty low cost system relative to some of the other higher performance systems on the market. So that's new construction. For people that have existing homes, a mini split is usually a nice way to get yourself into I guess a more environmentally friendly system without wholesale tearing out what you've got there already. So some of these existing buildings that are a little bit more energy inefficient, you can kind of step up the performance of the home by installing a mini split, but still have an existing like backup fossil fuel system, particularly up here in New England where it gets really cold in the winter. Sometimes a hybrid approach works well, and the mini split is good for that because it's got a pretty low price point.
Excellent. Did you want to start the presentations off then, Mike?
Yeah. So let's hear from each of you. Have a presentation. If you guys want to screen share, and we can have a little discussion in between. I'll give you a 5-minute warning, and then we'll try to wrap things up in no more than 8 minutes, plus or minus, just to make sure we have time to hear from everybody. So let's kick it off with Jordan.
All right, so can you all see my screen?
Yes.
Yes.
See your whole screen, including your icon. There we go. That's the first.
Great.
There you
And
go.
you can, all right, everyone, all good? Great. So I'm going to just talk pretty briefly about mini splits, the benefits, and a bit longer on the pitfalls, because I think that's what is generally more interesting, and hopefully you can take something home with you tonight that will be useful in the future. And I've intentionally put a picture of a house on as the cover slide because it's important to remember that systems are there to serve the people, not vice versa. So, you know, comfort is the end goal, and it's just as much dependent on the building envelope as it is the systems. And so, you know, for me, one of the things I love are designing the smallest, simplest systems possible, and that goes hand in hand with a good building envelope with the goal of providing excellent thermal comfort to the occupant. So, heat pump, mini split heat pump is basically the same as an air conditioner, as a refrigerator. It's a device that moves heat from one place to the other. So rather than just move heat from inside to outside like an air conditioner does, it has the unique ability to reverse its cycle and move heat from outside to inside. So in winter, it's extracting heat from the cold outside air, delivering it to the indoors. And in the summer, it's extracting heat from the indoors and moving it outside. And modern technology, you know, for years, there was this pretty bad stigma about heat pumps in cold climates that, you know, around 40 degrees or so, they would just start to shut down or move into electric resistance mode. And modern technology has it so that, you know, heat pumps are, you know, operating, you know, down into the single digits, into the zeros, into the negative digits, and doing so at pretty remarkable efficiencies, all things considered.
Yeah.
As I kind of touched on earlier, you know, smallest furnace or boiler that you're going to find on the market is about 40,000 BTUs an hour. You know, we're regularly designing houses that are 12,000 BTUs an hour, 20,000 BTUs an hour peak heat demand. And so the smallest available fuel-based system is going to be dramatically oversized for what we need. Mitsubishi makes single zone heat pumps down to half ton, 6,000 BTUs an hour, 9, 12, 15, you know, so they're down in the sizes that we want for what are hopefully all of the high performance, super insulated houses that we're all designing and building. As I mentioned, these run on electricity. which can be offset with renewables and are really good for life safety. Carbon monoxide is not a consideration. Indoor gas leaks and explosions, not a consideration because you don't have any gas. In New England, the natural gas infrastructure is really aged, and methane is about 30 times worse for climate change than carbon dioxide is. So if we can decouple our houses from the gas infrastructure, we are, rapidly moving towards a better future for the planet. Disadvantages, because I work in the Northeast almost exclusively, so I know there are people from all over the country, but this is kind of focused on kind of a heated dominated climate. Heating capacity, because there's less energy in the air as it gets colder, the capacity and the efficiency decrease as your outdoor air temperature decreases. In most of the areas where I work in, electricity is expensive relative to natural gas. So you might, despite having a really well insulated house, you might have higher operating costs than you would if you just had natural gas, which is really cheap. Although if you have a minuscule heating demand, then the absolute increase in expense is pretty small. And because it's an electric-based system, if the power goes out for an extended period of time, you've got to have some sort of plan. All modern boilers and furnaces have electric-based components, so they're not immune from power outages either. But with a heat pump, it means that your backup generator capacity might need to be a little bit bigger to handle your heat in the event of a long-term outage. Okay, so now the good stuff, pitfalls. These are the things that I constantly see, or not constantly, but I frequently see screwed up on, well, some of them are my projects for sure. Oversizing. So, we've heard for years about the dangers of oversizing our systems. It leads to short cycling, which is kind of analogous to driving and stopping traffic. It's really bad for your operating efficiency. It gives you poor dehumidification in the summer, or when you're trying to air condition and dehumidify. And what we see from the data is that the multi-zone systems, which are heat pumps that can connect to multiple indoor units, the modulation, meaning that the turn down ratio, like how well it operates at part load conditions, is nowhere near as good as the modulation at single zone. So in other words, I'm as guilty of it as anyone else. Having many indoor units combined with a single outdoor unit, one that needs to be a lot larger to handle those multiple indoor units, we're getting really poor performance because it's short cycling, it's not modulating, and it's just hurting the overall energy efficiency of the project. Driving and stop and go traffic.
Jordan, just let me interrupt. We're actually at 6 minutes in, so 2 minutes or so to try to get through. And I think you're doing okay, actually, but
super.
2 minutes less to fly through.
So here's an energy monitor of what oversizing looks like. Just rapid cycling between low and something less than high, but higher than we need. With all these systems, you always need to add refrigerant charge, and if you don't clearly specify it in the design documents, the installer might not inherently know that they need to add additional charge based on the amount of refrigerant pipe that they're adding to the system. Here's what an undercharged system looks like in terms of operating performance. That short cycling is even worse. It's basically cycling between off and full blast over and over again, which just really kills your operating efficiency. Refrigerant leakage. This is, I predict, over the next few years going to be a big, cat let out of the bag. This is a sleeping giant. I think that a lot of these systems are leaking. I think it's very difficult to get them very airtight or very vapor tight. 410A, which is a common refrigerant, has a global warming potential of 2,088, meaning that it's 2,100 times worse per pound than carbon dioxide is. So a typical system might have 5, 6, 7 pounds of CO2, meaning that if you have a bad leak and all of that leaks out, that's the equivalent of 10, 12, 14,000 pounds of CO2 entering the atmosphere, which might be the annual operating energy worth of CO2 or more of the building. So leakage is a big deal, and I think it's only going to become more prevalent in the coming years. our tests. I'm going to speed up a little bit. In cold climates, make sure you plan for your installation. You don't want to have this happen, and you don't want to have this happen either. So, have a little forethought about where you're installing your heat pumps so that they're not going to be buried in snow. Two ways of doing it that I have employed are to mount them to the outside wall of the house with a wall bracket or elevate them up on a stand. I have stopped doing the wall bracket because I've gotten too many complaints about vibrational noise transmitting into the building, and it seems to be not too predictable as far as like what houses it's going to be a problem in and what houses it won't. And it's really difficult and a pain in the ass to move this off onto a stand after the fact. So I just put them through that stand. And that's all I got. Quick, and thank you.
No, thanks. That was a good overview, I think, and did great on time too.
Stop sharing.
Excellent. Any panel feedback or questions on Jordan?
We did have one. We had one participant ask if you see the same short cycling issues in bigger commercial systems, in the VRF type systems.
So truthfully, I work almost exclusively on residential stuff, small multifamily. So I haven't really seen data on the larger VRF systems. It's not really different technology. It's the same compressors. It's the same manufacturers that are making both the mini splits and the VRFs. To me, there's no real distinction other than residential is generally considered mini splits and commercial is generally considered VRFs. So it wouldn't surprise me if the VRF systems are doing the same thing as far as short cycling is concerned.
Yeah, well, and I know Jake and Kristof may have more experience with those more commercial systems as well.
Mike, just one more note before we get to our next presenter. A few people have raised their hands, and I just want to, if anyone came late and they didn't hear it at the beginning, we're going to use the chat box for questions. So open up the chat box, make sure you select all panelists and attendees in the drop down, and throw your questions in there, please.
Okay, Mike, I can comment briefly. So as we all probably know, commercial buildings are less dominated by enclosure loads, more internal loads. So they have steadier loads, which implicitly helps them reduce short cycling. They're also not just heat pumps, they're heat recovery, so they can be heating and cooling at the same time. And I saw in the chat someone asking about a 4,000 BTU unit, like the miniest of minis. And that is rumored to be coming out as of tomorrow. It'll be next month. So it's coming out in June, supposedly.
Yeah, currently Mitsubishi makes a 6, not a 4.
Right.
So I've got a suspicion that the 6 is actually just a 9, that they're all.
Yeah, same weight, same size. Yeah, it's probably just the governor in it or something.
Great. Jake, do you want to present your presentation?
Sure, I can go next. I'll tell you what, Mike, why don't you run the slide deck? That may make it go smoother.
All right, this is always a little bit funky. Let me see if this works. Is that the right? Is that the right? Do you see the right thing? I'll get rid of the participant box. Okay, is it as big as it should be?
Yeah, I think so. I think that works.
Okay.
Okay. For people that are just joining, my name is Jake Staub. I'm from Ripcord Engineering, and Mike asked me to participate, so I appreciate the invitation as well as the distinguished panelists. I can't believe I'm sitting around with some of the big names in the business, but here I am. So my take on it was I'm going to present to you a little bit about, when doesn't what would cause mini split not to work well, and what could you do as a substitute. Just a lead in. If you go back one, Mike, I'll tell people I'm a native of Chicagoland. If any of you guys are out there in the Midwest, I identify. I know what systems you're using because I grew up with them. There's my credentials as far as formal education. I am a combat veteran. I flew for the U.S. Navy off of aircraft carriers and made 3 deployments. I served for 18 years, and then I got out and I needed something to do. And so I started off by figuring out how to build a passive house. And through that, me and my partner determined that we were going to start an engineering firm. In about 2015, we got Ripcord fired up. I finally figured out what I actually do. I'm actually the innovation officer of the business. I have yet to pass my PE test, but I've got to do that and pick up liability. Right now, Sonia carries all that. And our market here at Ripcord is luxury residential all the way through medium commercial. All right, Mike. So basically what happened is I had another luxury residential project called Moody Street. We're trying to stuff ducted mini split air handlers into this type of floor plan where, you know, you got these things above closets. The architects are real fans of stuffing these ducted mini splits above closets. And I thought, you know, instead of trying to route ductwork, there's got to be a better way to do this. The project, we normally see in luxury residential work, what they're doing is the client wants the radiant floor because they want that luxury warm floor feeling on their feet up here in New England, but they need AC, and that's how they get to this mini split combo. So this job already had radiant floor. I thought, well, if it already had radiant floor, why aren't we doing something like radiant cooling? Go ahead, Mike. And so I went trolling on the internet. Anybody recognize this guy? Kristof Irwin. So I found his video in 2017. He posted on the internet. And he was talking about this reversible chiller thing, which I had never really heard about. Right there is a space pack model. And this company, Masana. Like I hadn't heard of those two things. So it was informative. He kind of turned me on to this radiant cooling thing. In addition to that, like if you're a fan of ASHRAE handbooks, they also have a pretty good thing on radiant cooling in there. So that turned the light bulb on for me. Go ahead, Mike. And so I started going, you know, the mini split stuff is good, but, you know, it's kind of a bundled up thing. Like you don't know much about what they're using inside that box, what the compressors are like, or, you know, what technologies they're using to get, like Jordan's saying, well, this thing can go down to like -13. Well, you know, what piece of the box makes that happen? And if you're going looking for this stuff, it's EVI, which stands for Enhanced Vapor Injection. There's a couple other, I guess, definitions for it or spelling outs of the acronym, but that's basically it. And so if you go looking on the air to water side, EVI powers all these machines by like SpacePack, Chiltrix, AirMech. I put Nordic and Thermatlantic up there as well, but they don't really, well, actually Nordic does EVI, but Thermatlantic doesn't. But all this stuff is coming from Copeland. That's the compressor manufacturer for all these air to water systems, mainly. And all these icons that I'm presenting you, they're all hot links. So if you guys get the slide pack, you can click on these links and you can go and see all those companies. Go ahead, Mike. So you power it up with EVI, that gives you the low ambient performance. For radiant cooling, radiant heating and cooling, you're really selling these systems on the sex appeal. Like you can make them disappear, right? So you get the heat pump stuff, the heat pump performance, but you're doing water for your transport. And so you can make use of these different terminals like radiant ceilings and radiant floors without using things like boilers or typical chillers. Go ahead, Mike. The problem with going radiant, of course, in these more comfortable systems is you got to confront the cost of these things. Radiant, you know, like we were leading in on initially on the question, you know, why would you use a mini split? Well, mini split heat pumps are cheap relative to things like radiant systems. And so, you know, at some point you got to talk to the client about the cost of these things. Where Ripcord is working in the luxury market, we're working with A and B systems. And A and B systems are usually 9 to 14% of the project cost. So if you're running a, you know, if you're running, let's say, $500,000 job, you know, you should be expecting to pay about $60,000 for a grade A mechanical system. And so that type of cost will buy you into things like heat pump, radiant heating and cooling. Go ahead, Mike.
Okay, and Jake, we're at about 6 minutes right now.
Okay,
So
we're almost done.
doing good.
So why would you use something like a radiant heating and cooling system? Well, because, it's more comfortable. And so the other part of selling clients on, luxury, okay, it's luxury. Why pay more than a mini split? Well, because it's way more comfortable. That's kind of the selling point. There's 4 things there that you can read that, people usually key on for human comfort. But if, you're trying to sell the idea, you're going to do a much more comfortable system that tends to, you tend to get benefit from the client in terms of system cost by selling the comfort aspect of it. Go ahead, Mike. And then, why not use a mini split? Well, what if you're dealing with a luxury residential application that looks like this, where you've got, heating power densities that are all over the map. So in this case, what I'm showing you is BTU per hour per square foot over a floor plan, and the different colors represent how you're doing in BTU per hour per square foot, with the lowest being passive house consumption and the highest being, at 30 plus. Go ahead, Mike, next one. So cooling, same thing. If you got a house that's all over the place with heating and cooling power density, then you got it. Mini split is not going to work very well, as Jordan alludes to. Kristof is kind of making a comment too, with the smallest heat pump unit coming in at 4 MBH, or 4,000 BTUs an hour. If you got a house that's not working consistently across the power input, then you're going to have problems with overheating or overcooling in certain areas of the application. Go ahead, Mike. And that's it. So in short, mini splits are good, but they're not good for everything. So it's got to match your application, and a good engineer is going to be able to show you why you will or will not be happy with the choice you're making.
Thank you, Jake. Any questions or comments? I mean, essentially, it sounds like you're basically saying for more luxury projects, mini splits probably are not a good choice. I mean, can you use them on low load homes? Like, I mean, your house is extremely low load, and you don't have a mini split in your house, do you? You have a electric heater.
That's correct. Yeah. So here's the deal. Like, if you go looking hard enough about in Europe for what people are doing over there, there's this company called Dimplex. They're a heat pump manufacturer, air to water, but they also manufacture resistance heating, electric resistance heating. And it seems to me that once they get under a certain threshold, they will not use heat pumps, because they know about the short cycling aspect of the machine. They know about the limitations on the head size, the maximum head size. And so they just won't go that route. Or if they do go that route, they'll use an air to water system to get away from the short cycling aspect of it. They're not, Europe is not, it's not common, it seems, to find a refrigerant air to water, or air heat pumps. They do primarily air to water over there. I think one of the reasons why is because they're really turned on about the small loads across the project.
Interesting.
Air conditioning is also much less expected in most European places, and so having a hydronic heating system by an air to water heat pump, it makes more sense. There was a question, Jake, if you want to hit it, about handling latent load with a hydronic system.
I'm sorry, say that once more.
There was a question in the chat about how do you handle condensation and the latent load with a hydronic system.
Well, hydronic system, so you can use these hydronic systems like you use mini splits. So you can hook them up to heads that look like mini split heads. So in that case, you handle the latent load normally like a mini split guy will, which is not really much at all. Like, not much consideration given to it. For radiant cooling applications, normally, if you don't have a lot of money, you're using a typical mini split type fan coil as the first stage to suck as much moisture out of the air as you can. and then controlling water temperature to the radiant panel off the dew point temperature that you're monitoring. If you got money for the system, then you will put in like a European, they make a combination. It's almost like a mini DOAS where you got a combination ERV, and Christoph can, I don't know if Christoph used Masana's unit to do it, but Masana makes a unit where it's got an ERV in it, plus it's got a cooling coil in it.
Yeah.
So it dehumidifies, it can cool, and it'll run your ventilation air. So they're really, you know, if the Italians, I don't know what it is about those guys over there, but they got, you know, they got this thing dialed in, you know, in terms of the miniaturization of the DOAS system. Like commercial side would use a DOAS, right, with a cooling coil. Here we don't have that really, but in, you know, in Masana's case in particular, out of Italy, they have this technology where you can bundle it up all in one thing.
Yeah, it's very elegant. Masana, by the way, has moved strongly into controls. They're branching off into being able to control any radiant system. Yeah.
Kristof, do you want to queue up your own presentation or
Yeah.
Yeah. Okay. Great.
Go ahead.
You have a lot of slides, but it looks like you can probably get through some of them pretty quickly. So yeah.
They're pretty quick. So Jake, you know, I want to actually thank you for your service. I worked for the Navy for quite a while as a civilian research scientist for about 14 years. Is this working? Go ahead. Okay. Can you guys see a screen that says 10 million times?
Yes.
Yes.
Okay, so this is just a little bit of mathematical poetry that I just discovered, and if someone else knows it, that's a COVID molecule on the left. COVID's a living being that is dramatically affecting humanity. It's about 10 million times smaller than us. We are 10 million times bigger than COVID. What is it that we are 10 million times smaller than? Well, it turns out it's the planet. So this idea that something 10 million times smaller than the planet could not affect that system, you in fact have the COVID affecting the planet, right? So we have 10 to the 10th scale there. And the reason I bring that up is because what you see does matter. What you don't see does matter. What we're involved in today matters a lot. We're involved in a communication flow technology. This is how ideas move around our planet, and ideas are powerful. Notice this little note here that got actually put into the concrete along with this notch on the stairs. A little bit of humor here. This is about communication flow. Here's a swing set described by the client. This is how the architect thought of it. This is how the code official required it to be built. Notice the exit sign there. This is how the structural engineer did it with an auxiliary support. This is what we did, you guys. Put a little jet engine on it. Here's what the project manager understood. Here's what actually got built. And this is actually what the client wanted. So I thought I'd just be a little lighthearted to start out, but really it's very, very important that we think clearly, that we understand communication. And I'm going to get into that even more in a minute here. But so this right here is something else that's invisible. This is an example of about 15 years of business model innovation. Positive Energy Now, we start with doing actually firm culture. We go into architects and builders and we talk to them about the preconceived ideas that are deeply and dramatically affecting projects even before they get them, right? So then we do environmental design, mechanical design, enclosures, and energy and water systems that's resilient, renewable, and then plumbing and electrical. We do a lot of controls work on the back end. Super important to make all this work. You got to have expertise in controls, and then home performance assessment. Point is, this is an ecosystem. We're engineers, we're builders, we're architects, but we are part of an ecosystem. For any one of us to change roles, everyone else has to accommodate that. So one of the benefits of an ecosystem approach can be streamlined construction, right? Nothing makes the builder happier than knowing the size of the duct system, the trunk lines before they go in, right? This is somewhat of our go-to system here. This is not a mini split by the definition. This is a multi-split. It's VRF. We use the S-series equipment. We hide a lot of these in bookcases and cabinets, the PFFY radiator style unit. A lot of dedicated dehumidification. I'll talk about that in a minute. ERVs are a huge no-brainer, but for anyone in a humid climate, first you have a dedicated dehumidifier. You have to have a guaranteed dry, cool air mass or your ERV won't work. The motive force for your ERV is the dry, cool air mass itself. And filtration is, of course, doing nothing but getting more important. Controls, it is so important to really lean in and break your brain on controls. And this stuff will break your brain. We've hired into this. These are MN converters. This goes into a laptop on this end and connects to the communication bus. This is the new version on the VRF systems. This is now available for the more classic mini split lines, the M&P lines in Mitsubishi. But the data you get out of here in the hands of someone who understands it is invaluable to talk about how the system is running, why it's short cycling, what settings you can take. There are myriad dip switches, which is a little bit of a bad thing, but you can really customize the performance if you go into the higher end, more commercial equipment. So I live in a hot, humid climate. I don't have 70, 80, 100 degree delta T's like you do, but you guys don't get dew points in the 80s like I do, right? So mini splits, condensate management is a challenge, but this is something out of the ASHRAE handbook. There's actually a dehumidification column, and it's an eye chart, so don't read it. I just want to show you here that design temperature is 93 degrees at 77 wet bulb, but over here, the dew point is 77, it's only 83 degrees. So it's very important to know that usually when you get your peak humidity load, you are not getting your peak cooling load. Very important that you do both calculations. This is the roller coaster you get when you don't do both. I'm gonna pull out this day right here. You see that little shoulder, you'll see it show up here. When you have a daytime setback, the black is hot and cold, the blue is water, humidity, relative humidity. So no cooling, no drying. You put in a dehu and it goes away. You have no cooling, but every time you exceed a set point, your drying is held to your set point, 55 degree set point. This is an example of what we'd expect, right? This is your dehumidifier running at night, right? See, it's cooler here. This is the temperature line. Cooler at night, dehu running and running. By the way, the dehu is constantly monitoring the humidity. 30, 50 watts in there, depending on the unit. Then you have this thing called daytime heat. Heat of the day, the dehumidifier doesn't need to operate, goes back into night, the dehumidifier comes back on. Having a dedicated humidity system is absolutely critical. One of the big, for people with mini splits is they have this thing called dry mode. There's a lot of misinformation and mythical information going out there about dry mode means you don't need a dehumidifier. False, absolutely false. Energy use on dehumidifiers, this is 10 cents, 20 cents, 30 cents in my market a day. So what is it, 15 cents a day to run it? That's a, nice big latte or something. So this is an important slide. It's not really about the geekery of mini splits, but check this out. This is this societal system we want to change. This over here, this blue, this is that people are not asking us about mini splits. They're not asking us about air quality. We want to change that. The most powerful way to do that is to rethink the stories we tell ourselves about our homes. Unfortunately for us mini split manufacturers, the least powerful way is to talk about products. After that, we talk about how we do things and then our codes. But the most powerful change agent, and I think all of us on this call, I'll call it a call, we recognize that we're not trying to solve a problem in society. We are trying to help society avail itself of an opportunity here. We have the opportunity to live in carbon negative, healthy, fully resilient homes with energy and water systems based on sunshine and rain that come free. But how do you change the paradigm, right? Maybe you think about what the home could be. The home could be a health intervention. And if it's not, look, is there a flame retardant in this couch? That's a bad thing for air quality. Is there stain repellency on the fabric? Problem. If these scented products, cosmetics, there's a lot of things we can't see that really are important. What is our standard of care as an industry? Are we thinking about the thousands of pounds of air that we live our lives immersed in? And by the way, I had the benefit of seeing Jake's and Jordan's presentation, so I didn't have to talk about a lot of those pitfalls and refrigerant and things like that. I should just talk more about radiant maybe. So this is it. This is a dining room, right? We know about food in our society, right? Like I know way more about kale than I ever thought I would, but do you know that you breathe in about 40 pounds of air every day, about 10x what you eat and drink, right? Unless you're drinking a whole lot during this happy hour. Why not think of the bedroom as a technology to promote a deep night's sleep? Sound, vibration, light level, CO2, particulate matter, put you in deeper sleep. The same you with the same stressors sleep more deeply, and sleep is mood, appetite, everything, right? Everything depends on sleep, cognition. So I'm getting toward the end of it here. We talk about indoor environmental quality, having indoor air quality and thermal comfort as two of the components. It's very important to recognize that air conditioning and heating is not air conditioning. That's thermal comfort conditioning. You're pulling heat off of people. You're pulling heat off, sending heat to people. Indoor air quality is at least as important. It's important. So here's an example of one of our plan sets. We separated these out years ago as a subtle communication technology to the industry, to our clients, to say, look, these components here, they're just about thermal comfort. These components here, the filtration and ventilation, they're about your health. They're about indoor air quality. So a couple of big things about air quality. One, we are living in the chemical age, right? In our society here in the North America, this is us. We have chemicals exposures in our homes, and we're hoping they don't mean much, but we'll figure it out because we are the guinea pigs. This is huge. I don't think enough of us know enough about the indoor microbiome and microscopic biology that we live literally immersed in, breathing in, soaking in. The chemicals, by the way, can soak in through our skin like a transdermal patch. But when it comes to indoor microbiome, we hear a lot about mold. It's typically 25, 35% according to the indoor air experts, the functional medical doctors that deal with health. Most of it is damp building microecology, which gets into viruses and bacteria. So this is where the conversation is moving from mold to the whole indoor microbiome. My last slide, you didn't even have to give me the warning, Mike. This is what we're dealing with when we're designing a home, when we're working with our clients, when we're determining our business models. We're dealing with a Rubik's Cube. We have lots of different factors to think about here, right? And I think the big one that we're not paying attention to as an industry, and it's fantastic what you're doing here with Building Science and Beer, is raising societal awareness. If we can help people learn less about Game of Thrones and more about where they live, they will want these other things. And these other things are interlocking. You change one, you change them all. So, thanks.
That was great. Thank you, Kristof.
I'll unshare, right?
Yeah. Click the button there somewhere.
Okay. It should be
perfect. Yeah. Well, yeah, I'm not even sure what to say, but I think that was a good way to sort of tie it all together as to why this matters. And yeah. Any specific questions for Kristof, or should we open it up to chat box questions?
I think most of the questions are pretty general. Yeah, go ahead.
No, just that I can geek out. Maybe it'll show up later, but geeking out is kind of like watching pro sports. It's like where you put your brain when it's uncomfortable. And I think we as an industry, we need to go where it's uncomfortable, right? We need to go, why is no one asking me about an ERV? Okay, that's all. Thank you.
Well, first, all these presentations were tremendous. So thank you guys all for taking the time to do this. They were all really dynamite. I feel fortunate to have you here. The first question that came in was about cold climate design. To what temperatures can these mini splits function optimally? How much energy does the defrost cycle actually consume? And at what point does the coefficient of performance actually diminish at 2 or below 1?
So I can take this. So, I mean, the low temperature systems, whether they're by Mitsubishi or Fujitsu or whomever, they're generally rated down to negative 13 degrees Fahrenheit, which is pretty good. And they're actually operating in heat pump mode. There are no electric resistance elements by default in these systems. I think the COP might be around 1.5 at negative 13. but that's still 50% better than electric resistance.
Yeah.
So, provided that you don't have, some sort of, issue with low refrigerant charge that's killing your COP, you should not be encountering a scenario where you are doing worse than electric resistance.
I will weigh in. I will say that we've been tracking closely what happens on the BRF side, the commercial side, like the heavy commercial side, and the Hydronics Alliance has been banging on it heavy, hardcore. What they're finding on some of these systems, especially the big ones, is some of the manufacturers using electric strip heat to get down to the -13 regimes. So some of these COPs are seeing out of AHRI, that's the rating agency that does the ratings for these boxes, is not quite, it's not accurate. So in particular, DOE on the heavy systems, they're finding that their performance is about 50% of what they expected. So you have to be careful. I think the small systems are probably going to deliver what they say, but some of these heavy commercial systems are not going to perform. There are a lot of people getting bit right now, I think. And so it's not quite as cut and dried as you would think.
Yeah.
So we've had a few questions about ducted mini splits and integrating your balanced ventilation ERVs and HRVs with the ducting systems of ducted mini splits, and if that's possible and if it's a good idea.
I can comment on that briefly, super briefly. There's a fantastic article on Green Building Advisor about how to handle that. Is that too brief?
Too brief.
Yeah, so fundamentally, yes, it's quite possible. You have to be careful. There's, I don't want to get into it too long. You have to separate the entrance and exhaust from on the house side on the supply trunk. But there's no need to mince words. If you're doing an ERV, it should have its own distribution system unless it's a retrofit situation. And then even then you're probably overly constrained to make it done right.
Oftentimes, so in our practice, oftentimes we see contractors, they try and hold down the cost of systems by pumping the ventilation air into the air handler. So they won't do a separate duct system. And I'm getting a nod of the head. I'm getting a contractor nod of the head. Yeah, we got to keep the cost in line. So that's what happens.
So Travis, it's just a matter of communication flow, man. You need to communicate to the owner about the importance of their health.
That's fair.
I don't mean to be poking you in the eye, but it's the what is it? You saved them $1,000 of metal and $2,000 of labor, $3,000 on a $500,000 project. It's just a matter of value preference systems.
For sure. It's not a problem of, hey, this isn't worth it. It's a problem of, I already had to push hard for the ERV. Now I got to fight them to get the extra duct work. It's just, eventually everyone has their breaking point on their budget. Yeah. And so you know what I'm up against.
Yeah. Can you guys just
to piggyback on that and also tie it into Christoph's presentation. So when I talk to clients, I like to remind them kind of like the Maslow's hierarchy of what a house needs to provide. And maybe number one is structural integrity, that doesn't fall on your head. But number two, and I'm seeing this as increasingly strongly in the marketplace, number two is a healthy indoor environment. Your house needs to be a healthy place for you to live. And most of the people that I work with are spending hundreds of thousands, if not millions of dollars in the house. And the place where I wouldn't cheap out is the ventilation system, maintaining good indoor air quality. There are lots of other places to save money, especially ones that can be easily renovated in the future, such as your kitchen.
Yay. I was going to say. Kitchen appliance.
Ventilation system is there until the house is torn down or torn apart.
Yeah, I think you just shared that on your Instagram, Travis. Somebody made that really awesome graph that was talking about exterior insulation. But if you slide the ERV in there too, it's probably even less than that 1%. So, it's our job as the professionals to be like, hey, this is like bottom line. You have to have these. That's kind of what they're expecting from us, healthy indoor air quality, structure that won't fall down, and something that keeps you warm or in your case is dry and cool. We don't have that here.
We've stopped making certain things open to discussion with our clients. We don't talk to them about like our flashing details, like the structure of the system, like the structural engineer's design isn't up for negotiation. Like the insulation, the air sealing detailing, the mechanicals and the ventilation, these are kind of non-negotiable. And we can, if you're trying to save money, we'll find some ways, but we've got responsibilities as designers to not just think about this owner, but future owners of the house as well.
Yeah, in cars, did you guys have rubber or woven steel brake lines on your cars? Which did you ask for? Right, so the engineers decided that.
Well, I think we've heard that that one sales pitch. So essentially, we agree that these things are important, but we have a sales problem. One solution is to say this is how we do it. Period. That's great if you're in that market. A lot of us are in a market where we still have to convince people to do something that none of their neighbors are doing yet. I'm wondering if the whole COVID with a lot more people spending a lot more time at home, if that might help us with a sales pitch. You guys have just what's a quick one-liner we can use to try to convince people that this is a good idea if they won't just listen to our authority?
Well, I haven't done it yet, but I would basically tell them to go ahead and hold your breath. Like Kristof is saying, seriously, like you eat more air every day than anything else. So go ahead, hold your breath and see how long it takes you to give out, and so, the air is number one. The ventilation part, the V comes after H, but let's be honest, like if you put yourself in a plastic bag, you're going to die. That's all there is to it.
Yeah. My comment would be very similar. Thanks, Jake. Would be that you live your life while you're enjoying your home. You are literally immersed in that air mass. And if there are chemicals in that air mass transdermally going into your blood, right, you are breathing 12 to 16 times a minute, a half-liter tidal volume. Right, so it's pretty simple, but people don't know it. And the last one is like, do you buy organic produce? They say yes. You say, okay, well then you have the value preference system that you want good air quality. You want low pollutant exposure.
Excellent.
You could take that metaphor to swimming pools, or hey, do you want to swim in the ocean, or do you want to swim in this cesspool over here? With air being a fluid, it's a pretty easy sell. Like, we have the septic system. You can just swim here in this tank,
Or how about
I'm offering a cleaner environment if you're interested.
Right. But I identify, Mike, like, I built a passive house. I got a $300 heating system, but the ventilation system, the parts for it cost $6,000.
Right.
So it's expensive, but I tell you what, after living in it and working in it for, I don't know, about 5 years now, if I go into a crap building, I go into a building that's got a crap ventilation system, I do feel bad. Like I can feel the difference.
Interesting.
Yeah. So it's worth it. It's worth it. It's worth it more than that granite countertop. You can do that anytime.
Jake, that's an interesting point. At Fine Home Building for a decade and a half, I got to travel the country and visit a lot of really great high performance homes. And I was there for photo shoots. And after spending a full day in these homes, I didn't really realize what was happening at first, but it started to strike me that, wow, I really feel great at the end of the day working in these homes. I feel good. The air quality was good. The light in there was good. A lot of the things that Kristof mentioned earlier, like it all actually had an impact on my, not maybe my physical health, certainly my mental health. So that's interesting to hear you say that, Jake, that you feel that way as well.
Yeah, right. And getting back to the mini split part. So, we've got some architectural clients who think that mini splits are ventilation systems. Like,
oh my goodness.
So we've heard some comments from quote unquote educated people that, blow your hair back. So, part of this is client education too. I understand that, and architect education. It's not easy, but it's got to be done, unfortunately.
Yeah.
We did have a question just a moment ago about ventilation. I'm sorry, not ventilation, filtration with these systems. And is there an advantage to ducted? I think the question was, is there an advantage to ducted systems? So I think he was suggesting that you could do a better job filtering the airflow.
Yeah, I mean, I think ducted systems are better for thermal comfort, regardless. I don't ever do point source heating and cooling. You know, I'd like to have heated air delivered into every room. You could also heat a much larger portion of your house directly with a ducted system as opposed to a ductless system, meaning that you're less likely to oversize because you can have a single piece of equipment serving a larger area. But specifically, yes, you can put a MERV 13 filter on your recirculated air and do a better job cleaning. The important thing is to remember that the filtration and the air cleanliness is only as good as the maintenance of that filter. You know, general client awareness of the systems in their houses, even if they've come to people like us specifically for the houses that we do, you know, they don't necessarily inherently know that they need to stay on top of filter maintenance sufficiently.
That's right.
What else was wondering, and I think Christoph, you mentioned the amount of condensate that gets produced by these systems, and someone asked specifically, how do you deal with it?
Well, frankly, as a building science consultant, I often deal with it after the fact, as it's rotted its way down the wall. There is a way that as the wall units hinge in, they tend to make the condensate tube go uphill initially, and that's a problem. You've introduced an extra P-trap, which quickly gets filled with solids, and now you have a block. But no doubt about it, every mini split or multi-split, I have a dedicated dehumidifier in there. And I have it from a brand where I can get good access to their engineers. I mean, again, right, you think big picture, like, oh, I won't say that brand A might be the same price as brand B. They might weigh the same pints per day, but I can call these people. These people are in Bangladesh, and I don't know how to reach them. Just to that previous comment about how do we talk to people, here's one of the challenges, you guys, for all of us here. Our bodies experience the room that I'm in, and about 1/250,000th of what my body has experienced makes its way to my neocortex. So what I think I'm experiencing is one small fraction of what I'm experiencing, and fluorescent lights is just one example of that.
So a few people asked about the differences and differences between the refrigerant systems that I think Jordan mentioned and the CO2-based systems, and if you could talk a little bit more about the differences in performance between the two types.
Sure. So the CO2 system that I think is most prevalent in the US is the sanded heat pump water heater. I'm not aware of any space conditioning systems that are using CO2. CO2 systems are operated at much higher pressure than 410A, and so it's not feasible to do any refrigerant soldering or brazing with CO2 as a refrigerant. And so all of the CO2 systems are packaged systems that use some sort of hydronic distribution. So, you know, the major difference, aside from the global warming potential of the refrigerant, is that the CO2 can generate much higher temperatures, which is why it's frequently used as a domestic hot water system, as opposed to space heating, where you need 150, 140 degree water. But it could be a very promising technology for renovations in New England, where you've got all these houses with baseboard heat, you know, radiators that need to operate at 180 degrees entering water temperature. So that would be a really good fit for the future.
I will say every once in a while, Ripcord is approached by people, typically architects, that are considering using the Sandin as a combi system, so space heating and domestic hot water production. Sandin does list that application as suitable, or they have specifics on executing that application in their manual. but you have to meet very specific criteria to make that work. And if you're going to do that, then I would strongly recommend that you get a hold of a competent mechanical designer or mechanical engineer to ensure that your end product is going to perform correctly.
Yeah, though the sand in particular, the operating efficiency is dependent on the temperature of the incoming water to the heat pump. And so when you've got cold, city or well water coming in, it operates really efficiently at raising that up to 140 degrees. When you've got 100, 110, 120 degrees returning from a space heating system, let alone 140, 150, it's going to operate much less efficiently.
Mm-hmm. The Sandin comment also brings back in the business model situation, business model innovation. Sandin is a company that primarily makes compressors for automotive applications. They had the consortium with universities and the labs to develop this fantastic transcritical heat pump technology, but they didn't really have the infrastructure or the business model to send it out. And I think we know that Sandin now has licensed that to a couple of their reps. So I bet we're going to see a lot more innovation. But you're right, Jake. It's definitely worth careful design if you're going to use that for space heating as well as domestic hot water.
Yeah, for sure. It's so the origin of that technology was the Japanese government.
Right.
The program was called EcoCute, believe it or not. So if you Google EcoCute, you're going to a bunch of stuff on CO2 heat.
Can you say it with a Japanese accent there, Jake?
No, I can't. I can't. But oddly enough, people like Mercedes-Benz and Stiebel Eltron, actually, they've got a crazy CO2, like ERV CO2 heat pump combo to make domestic hot water. Like, there are people getting into that end of the business, but it's kind of like even in Europe, that's leading edge. Over here, it's almost untouchable, that kind of stuff.
Yeah. And then we'd have to figure out how to get society asked for that.
Right.
Why don't you speak to maintenance, any maintenance costs or procedures with I guess both ductless and ducted mini splits?
So, okay, so if you're a commercial player out there and you're using a big commercial system, you're going to get more lifetime out of a system than on the residential side. I've heard comments from the residential side that, and Kristof and Jordan may be able to back me up or correct me. The manufacturer is only on the hook to provide 7 years of continuity and part support for those systems. The commercial ones, they get a little bit more support, but still you have some compatibility problems if you're trying to upgrade a legacy system. As far as the annual maintenance is concerned, it's probably, it's similar to a DX system or a typical split DX system. If that helps at all.
I can make a comment. So a lot of the maintenance issues on the air handlers themselves are due to deficiencies in the air distribution system. So specifically return side leakage. If you're pulling in, fiberglass, dust, desiccated critter bodies into your return all the time, and then you're also not controlling humidity, you're obviously going to have a lot of problems. On the ductless system, filters are not magic. They are actually stopping physical matter, and eventually the physical matter can make its way through. So the simple thing about changing your filters, it's like changing your dryer lint screen. It's not a big deal. Don't be afraid of it. Just do it.
The manual, setting your clients' expectations properly about what maintenance is required is critical. Like, the wall-mounted mini split manual, I think, says to clean them every 2 weeks. How many people are doing that? I would say it approaches zero. On the design side,
zero.
On the design side, you really need to think hard, particularly for air handlers that are going to be hidden behind drywall or dropped ceilings or attic knee walls or something like that. You really need to think hard about who's going to access it and how they're going to access it. Many of the filters in some of these, like concealed ceiling air handlers are not that intuitive and they're not that easy to get to. Yeah, I don't think I can thoroughly give all the pros and cons about what types of air handlers to use and the filter maintenance, but don't half-ass it and don't let it be an afterthought, because those filters want to be cleaned at a minimum of every 3 months and probably more frequent than that.
Yeah. And as far as, the only, I'll have one more comment about this. Jordan has a good presentation about line length and refrigerant weight and all that other stuff. We're getting feedback from some of our larger housing authority clients that use a lot of these lightweight mini split systems. They're having trouble maintaining refrigerant levels in them. So, aside from the filter aspect of it, there's the refrigerant level aspect, which, that's going to be another one of these things. It's going to be a little bit difficult. We don't hear it so much from the single family homeowner, but the larger clients, they're having trouble maintaining refrigerant levels.
Yeah, Jake, what signals to the person operating the building that it's leaking refrigerant and it's getting low?
So Jordan will tell you short cycling is one of the frequent ones. Once you drop below 75% charge level, you get real inefficient performance. So you'll probably see your energy bills going up significantly. If you did a heating degree day normalized analysis of your home, your single family home, which probably it's probably beyond most people. But if you were to have a year, let's say, that was exorbitant in terms of energy bills, you may want to check or have somebody check the refrigerant level. I got a question for Jordan actually about that. How do you actually physically confirm the poundage in a system after it's placed in service? Like if it's leaking, how do you know how much is in there?
With the mini splits, you don't.
Yeah.
The only way to know is to have the installer, or what I specify is that in my drawings is that the installer needs to report to me measured line lengths of all the refrigerant pipes, and then he's going to do the math, and I'm also going to do the math as far as how much charge, and then I'm going to have him tell me how much you put in just to double check. So you have to do it ahead of time, and after the fact, it's impossible to know. And if you don't have the refrigerant line lengths measured, it's impossible to know how much you should put in. So it's technically speaking, it's a fucked up situation.
That's the engineer's term for it, zero.
Yeah.
So what's best practice then in terms of keeping that in check and really monitoring that instead of waiting until you see a loss of efficiency in your energy bill? Christoph?
Well, no, actually, I'm not answering your question. The best practice is to go hydronic with a very small refrigerant circuit. But I didn't answer your question. So I didn't raise my hand to answer that question.
That brings up a good point. So the benefit of hydronic systems is it's quote unquote hermetically sealed at the factory, so it shouldn't leak refrigerant, right? So
yeah, you can get that's definitely true. You can get much better quality control over the refrigerant line sealing if it's done in a factory setting.
yeah.
And the volume.
And you could have governmental agencies hold the factories to task. It's like car ACs used to be an incredible source of refrigerant leakage until the government stepped in and passed laws, and now they're not.
Yeah. Has anyone here read Drawdown, the 100 Things to Do to Prevent Climate Change?
Yeah.
So yeah, it's those freezer chests in the Quickie Marts that we don't even have the energy to lift the lid anymore, so they sit with the lid open. I mean, goodness, are we that lazy? Those are where the majority of the refrigerant leaks, according to that book, are coming from.
But oddly enough, I was corresponding with a guy at Fraunhofer Institute, which is a big time energy, analysis and whatever. They're into this building science stuff. And oddly enough, he was asking me, well, do you know anything about refrigerant leakage? So, I mean, it's probably a pretty big deal, only there's not a lot of data on it right now.
Yeah.
Yeah.
I mean, it's a challenging issue, and it's fundamental to what we've been asking. So, as a society, since the post-war building boom, what have we asked air conditioning manufacturers and installers for? Low cost and speed of installation, right? It's got to be simple. It's got to be cheap. 70 years later, what do we got? I know I sound like I'm broken record. Sorry.
We had.
Okay, I think you're preaching to the choir.
Once you put these goggles on, okay, thank you. There you go.
Yeah.
Hard to take them off.
So can I ask a question? Do
Of
the
course.
the other two panelists, you guys look at power density at all, or no?
Yeah, I call it thermal flux density.
Okay, yeah.
Thermal
Jordan?
flux density. That's
Flux capacitor density. I like it. All right.
EUs per hour per square foot, right?
Right.
We call it EUI.
And what do you find is the max acceptable for heat pump application? You got a max or
30.
All right, cool. Jordan?
Yeah, I mean,
40.
Again, we're doing all ducted systems, so we're, and with the new, Mitsubishi makes these SVZ and, large air handling systems. So, if it's a large, heavily glazed room with a high peak energy demand per square foot, we're distributing around the perimeter, and so I'm not so concerned if it's got a particularly high per square foot.
And how are you guys, so going into low load, how are you guys treating, how are you guys doing zoning, or how you justifying putting one head in a bottom floor,
So my general rules of thumb are a zone per floor, and then we can start negotiating. I really don't want to, if you've got heavily glazed rooms, then we'll think about a separate zone. Heavily glazed in the opposite direction from the rest of the house, then we can think about a separate zone. But really, this is where architecture and thermal envelope design and HVAC design don't stand apart from one another. These need to be done in conjunction.
Absolutely.
So that the envelope is responsive as well to the thermal.
Mm-hmm. I mean, so the simple answer is you zone it by load profile, as you're talking about, Jake.
Yeah.
But how do you do it? Right behind us here, we have two zones set up on one air handler. It's a PEFY, compact ducted, and we have the one zone system. And it's a, you guys know about that? Or I don't know if I should talk about it, but basically it speaks the control system language of the manufacturer. So you get a little plug-in board for Daikin or Mitsubishi.
Yeah, air zone.
You don't lose any loss of performance, and it'll, figure out which zone it's serving and which is dominant. So it's quite elegant, actually. It seems to be working.
Okay, so that's a little bit different. So have you guys heard of air zone?
Yeah, air zone, one zone. One's the parent company and one's the product, and I can never keep track.
Yeah, AirZone, they work with all the different mini split manufacturers. So this might be a good tip for all those listening in the audience. If you get keyed up on AirZone, that'll allow you to do it's like a multi-zone air handler setup for your mini split system or your split system. Doesn't work with all of them, of course, but it's one tactic and technique that we use. We've
got a connector issue that we got a little YouTube video. Miguel's here on the chat. He can probably put it out, but it's a fantastic product, but we've had a lot of problems with wires falling out. And as Jordan was talking about, they don't fall out in places where people can get to. So we haven't quite worked that out as an industry. We're in the process of it.
Huh, interesting.
Yeah, well, so the video, if you do it right, the wires don't fall out. I want to be clear. It's not like it's designed so that the wires fall out.
Well, in terms of so these low load applications, these low load homes where you got, here's the one thing we've seen at Ripcord Engineering. These architecturally led projects, the client's got enough money to hire an architect, so inevitably they want this thing zoned to the max. And one of the only ways to deal with that we've found on the cooling side, at least, is to do something like an air zone where you're dividing up a single ducted air handler into 4 or 5 tubes that you can run to your mini zones or your micro zones, we would call them.
Yeah.
That's really the only way we found to handle that situation. That applies to commercial as well, too. I think we got a question about a commercial side. that same thing applies where you got, you know, little offices in a commercial application. You need to somehow zone up that ducted air handler and air zone. They're OEM, they're in the OEM system for a couple of different VRF manufacturers.
Yeah.
So we also had, you were just talking about low load homes. We also had a few people, I think, ask about very small homes. I think someone mentioned 400 square feet. Another person mentioned 600 square feet,
Yeah.
and asked for recommendations for equipment for such small spaces.
Move to Eastern Europe. They'll have
Yeah. So we've had a couple of jobs, multifamily residential with, you know, it's kind of like a micro house, right? It's like 400 to 600 square feet. To address that, we've tried on one project, this company called Innova, INNOVA. They make a dual ducted, it's like a glorified PTAC. So it's better than a PTAC. It acts a lot like a mini split without the outdoor condensing unit.
Right.
And it's inverter powered, so you can turn it down. I forget what the minimum is, but something like a 8,000 or 9,000 BTU per hour max, all the way down to maybe 2. It'll turn down to like 2,000 BTUs an hour. And the performance, the cold weather performance isn't quite, it's not as good as the high perf like Mitsubishi stuff, but it'll get you down to, I think, 17 degrees on the heat pump, which is not too bad.
Right.
So if it only gets down to 17, then do you switch over to backup like electric resistance below that, or does the fan heater kick in, or how does that work?
Yeah, you back it up with electric resistance, and you know, so here's the deal, right? The engineering side, if you look at the bin hours of what you're dealing with, even in the Northeast, you're not dealing with a lot of bin hours below 17 degrees. So a lot of the people that are coming in at this problem as architects or clients, they think you got to hit this thing 100% with a heat pump. The problem is got to hit 100% with a heat pump. And when you're dealing with these expensive systems, and believe it or not, these heat pump systems are expensive, you don't need to hit 100% with the heat pump. You can hit, you know, if you're doing 80% sizing, you can get 95% of your bin hours with that. So, you know, these couple bin hours, you know, at 17 and below that you're not hitting with the heat pump, you're never going to see that in your energy cost or energy consumption side, really.
Oh, that's good to know.
Something like a thermal mass might help as well, Jake. You know, just store some of that energy, let it re-radiate out. It's mostly cold when it's mostly night, and most people are in bed under the blanket.
Mm-hmm.
Yeah, I mean, the real answer to those who are wondering what to do about a 300 to 400 square foot house, building, room, is first, you got to do the math. You know, there's no one size fits all answer. You know, do the math, do the loads. What if that's in Minnesota, the answer is going to be a whole lot different than that. That's in Arizona or Southern California. Mm-hmm. So, you know, a single zone wall mounted heat pump might be a good fit. It might be oversized. It might be undersized if you're in Quebec or somewhere. Who knows? You know, so, you know, you're not to cut my own legs out for me, but like listening to me talk on the Zoom is not a substitute to like getting a proper system design. You know, don't be afraid of the math. Don't be afraid of the numbers. Run.
Yeah.
I have one comment on achieving the performance that the rating agencies show on their spec sheets. The way to do that is to keep your line length short as possible and keep your system on a wall-mounted ductless unit. The longer you make your line lengths and the longer the ducts get, the less you're going to realize that advertised performance.
Yeah. To know. We're at 7:26 or so. Do you guys want to just go around and what if there were one or two things you'd want the audience, which are a mix of anything from novices to mechanical engineers, what's your best tip or piece of advice you want to leave people with? Whoever wants to jump in.
I can go first while you guys are thinking of it. Well, first of all, I want us all to be thinking about that COVID virus 10 million times smaller than us, 10 million times smaller than the Earth. But thinking of indoor space, right? Conditioned space is conditioned to have people in it. Thinking of it as about human thriving, I think it's something we all want. We want to thrive. And I think that our problem is we think about our home as a visual, spatial, economic play in our lives when it is and could be so much more. So that would be my final takeaway.
Interesting. Anybody else?
Go ahead, Jake.
The number one thing I would say is use the right tool for the job, please. Like if you want all this low load stuff and luxury this and there is no Swiss Army knife that's going to address it all. So your application, your specific application, if you're not using the right tool for the job, you're not going to have good results. So make sure you know what you're doing, make sure you use the right tool for the job, and you're going to be okay.
Excellent.
Don't
What do you have, Jordan?
do the math.
Do the math.
Don't be afraid. The math is your friend. Don't be afraid of the math.
And to be specific, the math is ACCA's Manual J. Is that correct? Is there anything? Are there other math calculations we need to know?
Yeah, I mean, Manual J is one way of sizing systems. It's probably going to give you a slightly oversized system because it's inherently very conservative calculation. PHPP, which is the Passive House Institute software, or Wolfie Passive, which is Fias's software, which are basically the same software with different interfaces. That's got a peak load calculator as well, if you want to be a little bit less conservative. Do the energy modeling to see what the benefit is of heat pump versus electric resistance. And to Jake's point, he's obviously very concerned about keeping capital costs down. PV is very cheap right now, and so you might find that if you've got a 300 square foot house and you don't need AC, electric resistance plus a few more PV panels is a much more economical approach than a heat pump with a refrigerant-based heat pump system. So there's lots of nice, fun math out there. Don't be afraid of it.
Excellent.
Oh, and number one, do not sell human comfort short. Period. You're living with your own nightmare if you get it wrong.
Got it.
It's a scary industry that Jake, Jordan, and I are in. I mean, you get this stuff wrong, you're in someone's psychology, and they're pissed.
Yeah.
Right. Well,
Sorry.
Yeah.
Like electrical, if you get it wrong, you know it right away. Plumbing, you get it wrong, it leaks right away. Mechanical, it's completely qualitative to do these designs. It takes some years of experience and nerves of steel. And I want to thank you guys for inviting us Southerners up to the New England area or wherever we are.
Yeah. No. Well, thank all of you a lot for coming and sharing all these tips. This was a really great conversation. I think we covered a lot of territory, and we never know quite where it's going to go. And I'm sure we missed a lot of important topics, but I think we covered a lot of really good stuff. So thank you very much, and thank you to my co-host. Thank you to the audience for listening in, and whoever listens to this in the future. I hope everyone has a good night.
Yeah, I wanted to say thank you to everybody too. And for as much as we like to pretend that building science only exists in New England, it clearly is other parts of the country as well. So thank you to the Southerners for joining in and giving us a little bit of education. Travis likes to remind us sometimes.
That's true. Let's all retire to the nerdery with our calculators. We'll see you next week.
All right.
Good night.
Good night.
Thank you.
Thanks, everybody.